Good afternoon, class. Here's exam 4, covering chapters 4 and 5. Application of differentiation, integral, and section 6.1 areas between curves. Here's part 4, covering 5.4 indefinite integrals and the net change theorem, 5.5 the substitution. So what is a net change theorem? In essence, is the FTC. So the integral of a rate of change is the net change. The integral of a to b f of x dx is the integral of a to b capital F prime of x dx or capital F of b minus f of a. This principle can be applied to all of the rates of change in the natural and social sciences. So continuing with the integration, in order to do so, first and foremost, we are going to change this to x to the power 1/2. Then this one has exponent 1, this has exponent. We make up two fractions. This one gives you x to the power 1/2. This one x to the power of negative 1/2. And so let's start with this 1 over 1/2 plus 1 x to the power 1/2 plus 1. This one 1 over negative 1/2 plus 1 x to the power of negative 1/2 plus 1. Since there's nothing else, we're going to add a constant right here. And believe it or not, this is the only calculus step. 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. 1 over 3/2 makes it 2/3. 1 over 1/2 makes it just 2. And we are done. But we could rewrite this as x squared of x, and this one as squared of x. Just in case. A bacterial colony increases at the rate of R of t equals 2.2 e to the power 0.4 t bacteria per hour. The initial population is 800. Find the population after 12 hours. Well, if this is the rate, the antiderivative represents the population. So capital R of t represents the population, and capital R prime or lowercase r of t represents the growth rate, and the initial value R of 0 equals 800. So according to the accumulated change or net change theorem, the amount of increase is the integral of this from 0 to 12. Therefore, we write the accumulated change or the increase in population after 12 hours is the integral of lowercase r of t dt from 0 to 12. So plug in. And remember, the exponential, the derivative, and the integral are the same. Differentiation we multiply by 0.4, integration we divide by it, 1 over k. So we're going to divide by 0.4. 2.2 divided by 0.4. Two divided by 4, 5.5. Plug in 12. You can take the 5.5 out. Plug in 0. And of course, this is e to the power of 0, or simply 1. But anyways, you have to put it into a calculator. And because we are dealing with the population, we are going to go with the whole number. Number 2 next to it is 8 goes up. And the initial value of 800 is added. So R of 12 is 800 plus 663, which makes it 1463. Pretty straightforward, everybody. Now, let's look at a slightly different methodology, and that's to find capital R of t. To do so, we differentiated this and we got this one, so let's add a constant. with initial value r of 0 equals 800, we can find the constant. So r of 0 is 800, 5.5 times e to the power of 0, e to the power of 0 is 1. So this entire thing is 5.5. And c becomes 794.5. You replace it. This is capital R. Now all you have to do, plug in any number you want, for example, 12. That gives you the same answer with the proper rounding, by the way. The advantage is that you can do this for any time. If they said after 10 hours, replace it with 10, 15 hours, replace it with 15. So that makes it nice and easy. We want to evaluate the integral, and the very first thing we notice that we have to use our integration trigonometric identities by replacing sine of 2x with 2 sine x cosine x. We can drop the common factor and we end up with 2 cosine x dx, which is 2 sine x plus a constant. So it's pretty straightforward. I hope everybody is okay with that. So again, knowledge of trigonometric functions and their identities is a must here, as you can see. In part B, again, this is 1 over x dx. So you know it's a natural law. And evaluated by plugging in the two numbers. And this uses the quotient rule, becomes ln of 6/3 or ln 2. Very straightforward, everybody. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? And they want us to round it. Well, notice this is the derivative of some function. So if we let something, for example, L of x, because we're dealing with the length, represents the length of fish, you can say f of x, whatever you want, doesn't matter, at hx, then the growth rate is L prime or dl dx or 29 e to the power minus x with the initial value L of 0 equals 1 centimeter. Again, this is the accumulated change, and we're going to do it two ways. The amount of increase over the course of the first 4 years is the fundamental theorem of calculus, the integral of a to b, the integral of 0 to 4, and that is the function. So the answer is itself, you put a negative here because you have to divide by it, and you can take the negative 29 out, not that it makes much of a difference. Evaluate it from 0 to 4. Although this is 1, but you have to put the rest into a calculator. And we put quite a few decimals to begin with. L of 0 is 1. We want to add it. And finally, since they want 1 decimal, so 4 next to it is 6, goes up to 5. We are done. And what's happening is, this is the methodology by which you can find the amount of increase and add to the initial value. However, we can find the derivative in general, and remember, we found it to be this one, so we add a constant with the initial value, L of 0 equals. So this is a general solution. This will help us find one of those. So L of 0, as you know, this is 1, so negative 29 plus what number equals 1? Must be 30. So that's the function. And since we are interested in finding how long the fish is when it's 4 years old, replace the x with 4, you get exactly the same answer. Again, the advantage is that if they ask you for several different years, such as after 5 years, 6 years, 7 years, in one shot you plug it in, otherwise you have to go through these processes. Yes. But anyways, I just wanted to mention both are doable. A particle moves along a line so that its velocity at time t is given as v of t equals t squared minus t minus 6, measured in meters per second. Find the displacement of the particle during the time period of 1 to 4. Find the distance traveled during this time period. So first I want to explain the difference between the two concepts. If you go from point A to point B, this distance that you're going to cover is the displacement. But you may not be able to go straight from A to B. You may have to go like that. And so the distance would be adding all of this. I hope you see the difference between the two. So that's the concept I want everybody to see, first and foremost. So in general then, distance is the integral of t1 to t2, and you put the velocity in an absolute value because, for example, positive here, negative here. So a1 plus a2 plus a3. However, displacement, you don't put it absolute value. The integral of t1 to t2, v of t dt, it's a1 and a3, they added, but a2 is being subtracted because it's negative. So that's the difference between the two. Okay, that's important to understand. So if that is the case, we want s of 4 minus s of 1, which is the integral of 1 to 4 v of t dt. So that's very straightforward, everybody. We're going to easily find that. And that would be the integral of t squared minus t minus 6 dt. This is 1/3 t cubed minus 1/2 t squared minus 6t from 1 to 4. So you're going to plug in 4, you're going to plug in 1, and I'm going to leave it for you to evaluate. It becomes negative 9/2. In essence, it moves to the negative direction. The particle moves 4.5 meters towards the left. If you go back to the units, meters per second, that's why it's meters in the negative direction, in this case, left. Okay, so that makes it very straightforward as far as the first part is concerned, and we are done. Now the distance, however, let me erase my work, is the same thing, but in an absolute value. Okay, so in order to do that, I want to remind you what is an absolute value. Absolute value of x by definition is x if x is larger than or equal to 0, negative x if x is less than 0. It's important to know the meaning of this is the opposite of x. Doesn't mean negative. In fact, it is supposed to be positive. So in order to figure out where this function is positive, where this function is negative, we have to do the sign graph. So we have to factor the v of t. You want two numbers, the product is -6, the sum is -1. So we factor it into t plus 2, t minus 3. So we put a number line from negative to positive infinity, although we don't need that. We really need from 1 to 4, but just in general, if we didn't have that, from negative to positive infinity. That's what t is, or the independent variable. And you're evaluating v of t, okay? And you know specifically t plus 2, that means at -2 is 0, t minus 3, at +3 is 0. So you put negative to positive infinity, you put these two numbers here, and v is negative. Now, what happens to the velocity at different, sub-intervals? To the left of -2, between -2 and 3, between 3 and infinity. In fact, we just want from 1 to 4, but let me just do the entire thing. If we look at this one, because it's factor degree 2 and 2 factors, or this one has exponent 1, this has exponent 1, they will alternate. So the fastest and easiest way to find the idea, you use p test points, -3, 0, let's say 4. I'm going to only look at 0 and the rest of them alternate because of the fact that it's only 1. So if I put 0 here, I get -6. So that means negative here, positive here, positive here. Okay. And since I want it from 1 to 4, and to the left of 3 is negative, from 1 to 3, it's negative. So I'm going to use the negative of that to make it positive. And from 3, because it goes all the way to 4, from 3 to 4, we just use the function. That's how it works based on that. Again, we really should go from, because t is time from 0 to infinity, but I just wanted to show you how this thing works in general in case. So we are going to put this one, we're going to put the function here. This one, we're going to negate that, minus t squared plus t plus 6. And so as you can see, this is negative 1/3 t cubed plus 1/2 t squared plus 60, and this one is the same as this one. Again, I'm going to leave it for you to evaluate it. You get 61/6 precisely, roughly 10.17 meters. If the distance is not positive, we've made a mistake somewhere. The displacement can be positive, can be negative. Okay, but this must be positive, and it's extremely important that we pay attention to that. Difference between the value of a definite integral and total area. Find the area between the x-axis and the curve y equals cosine x. In other words, between 0 and 3 power 2. As you know, this, by the way, this is the graph continues indefinitely on both sides. And this, if you stop here, it's just one complete cycle, but we just want it up to 3 power 2, meaning we want this one plus this one. And if you evaluate this from 0 to 3 power 2, just the way it is with the cosine, you end up with a negative because, as you can see, this has a larger value than that. Instead, you have to go with the absolute value. And since you clearly see that it's positive here, so from 0 to power 2, you just drop the absolute value. From power 2 to 3 power 2, you go with the negative of that, or minus cosine. This is positive. Let me just show what I did here. So I'm showing you this is positive, this is negative, and so the positive part, we just drop the absolute value, the negative part, we don't. We, with the positive part, drop the absolute value, with the negative part, we have to negate that. So this gives you sine x from 0 to power 2 minus sine x from power 2 to 3 power 2. So this is sine of power 2 minus sine of 0 minus sine of 3 power 2 minus sine of power 2. Power 2, we know sine is 0. So 1 minus 0, we keep the negative. Sine of 3 power 2 is negative 1 minus, this is positive 1. So I hope you see that this is negative 1 minus 1. So in other words, this is negative 2. And this makes it positive. They add up to 3. So very straightforward. And you should be very careful when we come with that. Remember, this is the area under the curve. It must be positive. Now, What about the value of a definite integral? What if we didn't pay attention to that and we just evaluated this? We get sine x from 0 to 3 power 2, which is sine of 3 power 2 minus sine of 0. This is 0. And as you know, sine of 3 power 2 is negative 1, which means this area must be 2. This area is 1. Okay, so 1 minus 2 becomes negative 1. That's the idea. So you want to be very careful with that. Section 5.5, the substitution. Integration by substitution is the reverse process of the chain rule in differentiation. Let's differentiate capital F of g of x using the composite function. So it's simply capital F prime of g of x times g prime of x. And normally we let capital F prime be lowercase f, or the integral of lowercase f is capital F. Normally the notation we use. So it's f of g of x, g prime of x. So if we go this way, it's the reverse process. That's all we are saying. Now we let u represent g of x, then du dx is g prime, and du is g prime of x dx. And so the integral of f of u du is capital F of u plus c, where u is g of x. So over any interval for which u equals g of x is continuously differentiable, and f is continuous on the range of this function, the following relationship holds. The integral of f of g of x, g prime of x dx, where g of x is u and g prime of x dx is du. We have the integral of, if we replace it, f of u du, which is capital F of u plus c, capital F of g of x plus c. So that's pretty straightforward. All right, we want to integrate, and the tip is for integration. You look for a function u equals g of x anywhere in the integrand and its derivative du or g prime of x multiplied by dx. When we have polynomials and nothing else, there is one polynomial 2x, there is another one x squared plus 5. The more complicated one, in this case x squared plus 5, is a choice of u. If I differentiate this, du dx becomes 2x, and du is 2x dx. You can always skip this one, but you can't skip this too. You must write what is u, what is du before you can move. So we're going to move the 2x next to dx, so it becomes clear to the reader. This is u, this is du, and this is the integral of u to the power of 30 du, which is a simple case of a power rule, 1 over 30 plus 1, u to the power of 30 plus 1, and a constant. Reverse substitution gives us the final answer, 1 over 31, x squared plus 5 to the power of 31, plus a constant that we are talking. So it's pretty straightforward, everybody. Same thing here. We deal with a couple of polynomials. Clearly, this is a more complicated one, is a choice of u. The first parenthesis, x squared plus 3x plus 5. Number 9 can be inside or outside. The integral sign makes no difference. If I differentiate, I get 2x plus 3. That means du is 2x plus 3 dx. So clearly, we are dealing with u and du here. In other words, 9 u du, which is 9 halves u squared plus a constant, reversing the substitution. 9 halves, parentheses x squared plus 3x plus 5 quantity squared, plus a constant is the final answer. So that's pretty straightforward. So we are repeating the question. It's worth looking at it again. The more complicated one is a choice of u, x squared plus 5. U dx is 2x, so du becomes 2x dx. So this is u, this is du, and u to the power of 30 du. 1 over 31 u to the power of 31, and a constant reversing the substitution will give us the answer, and we are done. All right, what about this one? We have the integral of 5x to the power of 4 e to the power of x to the power of 5 dx. Anytime e is involved, and it has an exponent, normally the exponent is a choice of u. As you say, if u is the exponent x to the power of 5, du dx is 5x to the power of 4 dx, which makes du 5x to the power of 4 dx. Therefore, we're going to move 5x to the power of 4 so it becomes clear. This is e to the power of u, this is du. The answer is e to the power of u plus a constant reverse substitution gives us the final answer. By the way, if you have any doubts, as always, at the end you can differentiate the result, gives you exactly the same thing without the dx. Now, what about this one? Again, the exponent is a choice of u, and the u happen to be the same, 5x to the power of 4 dx. Now, I'm going to move x to the power of 4 next to dx, and I notice this is e to the power of u, but this is not du. So what do we do? In most texts, they solve for dx, everybody, and you can go that route. But an easier way would be, because 5 is a number, if I put it here, I can undo it with its reciprocal, 1/5. By the way, you can put both of them in or out, it doesn't matter. It's just a number that remains. So this one now is e to the power of u, and this one with the help of 5 becomes du. So the answer is 1/5 e to the power of u and a constant. Reversing the substitution, 1/5 e to the power of x to the power of 5 minus 2 plus a constant, and we are done. So, in short, if e has an exponent, that's a choice of u. If the du is missing some number, that means it's a multiple of what you need, or a fraction of what you need. We can multiply by a number if you like, and undo it as we did here. You can only do that with numbers, but as I've mentioned, in most texts, they just solve for dx. I will look at a simple example that involves that. What about these two cases? And I want to look at them side by side. We are dealing with rational functions, but even if they're fractional format, the very first step is simplification, if we can. So let's see if there is a common factor. And to do that, I'm going to start with this one. This one has the coefficient 2, which is a prime number, 2x and x. This one is 3 and 1. One of them must be negative. And I'm going to assume no one has any problem with that. The only thing is, see, 2x times x is 2x squared. 3 times negative 1 is negative 3. You have to check the middle term as follows. This one is 3x. This one is minus 2x. Do they add up to plus x? Yes. So now that they do, as you can see, the numerator can't be factored, so there is nothing we can do. The denominator is a choice of u. And if you differentiate, you get 4x plus 1, which makes du 4x plus 1 dx. Remember, dx belongs to the numerator. That's why we're going to rewrite it so it becomes clear to the reader what we have, du over u, which gives us a natural log, and we replace the u, we are done. ln of absolute value of 2x squared plus x minus 3 is a constant. You have to keep the absolute value sign because this expression can be positive or negative. What is the difference between a and b? The b, the denominator is the same. The numerator, we can factor it, which means now I can drop a common factor of x minus 1, and we must work on the simplified version. So now that we can no longer simplify it, u is the denominator 2x plus 3, and du is 2dx. So I hope everybody can see that we have 4dx, which is not a big deal, is 2 times 2dx. So I'm going to rewrite this as a product of 2 times 2dx. Remember, this is 4dx. So therefore, you're dealing with du over u and the same natural log. Of course, the 2 remains. Reversing the substitution, 2 ln of absolute value of 2x plus 3 plus a constant is the final answer. So the point being, simplify. Now, what if we have the reciprocal of this? We must use long division. What if we have the reciprocal of that? Because we simplify to this, we get the reciprocal of this one, 2x plus 3 over 4. This is half of x, this is 3/4. And there is no need for substitution. X gives you half of x squared, with this one becomes 1/4 x squared, 3/4 x, and a constant, and we're done. It's that simple. We're going to move on, and again, we have a couple of fractional expressions. This is not a rational, this is a rational function, makes no difference. The first step, simplify if you can. Because we can't, the denominator is a choice of you. As you see, the derivative is e to the power of t, which makes du e to the power of t dt. Rewrite so everybody can see the numerator is du, the denominator is u. Again, it's a natural log. And replace it with 5 plus e to the power of t. Notice, because the expression is positive, you could lose the absolute values. For part B, the first step is to simplify if we can. Can we simplify it? And the answer is no. How do we know that? I'm talking about the denominator. Can we factor it? Okay. Well, I'm going to remind you of what we have studied before. The quadratic formula is in the form of ax squared plus bx plus c equal to 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. And b squared minus 4ac is called a discriminant because it gives us a lot of information. If it is positive, we have two distinct real solutions. If it's 0, we have only one real solution, which is also a rational solution. If it's negative, we have no real solutions. We have two complex solutions, a plus minus bi. Furthermore, if it's a perfect square number, then it can be factored. So is this b squared minus 4ac perfect square number? Let's find out. Well, I hope you see that for this one, a is 1, b is 2, c is negative 1, and so b squared minus 4 times a times c is 8, which is not a perfect square, cannot be factored. Denominator is a choice of you. So if I differentiate, du dx becomes 2x plus 2, or two times x plus 1. So du is the same thing times dx. I'm going to rewrite this so it becomes clear to everybody that you have everything in order except 2. And remember what we do. You can solve for dx as what they do in most texts. But because 2 is missing, I can put the 2 here and undo it with its reciprocal, 1/2. Now, the numerator is du, the denominator is u. Again, it's a natural log, so 1/2 ln of absolute value of u plus a constant, reverse substitution, 1/2 ln of x squared plus 2x minus 1 and a constant, and we are done. And we have to keep the absolute value. Now, what I want to do, again, I want to look at the reciprocal. The reciprocal of this one, you have to do long division. It can be done with synthetic division. This one, the reciprocal of this one, make up just 2 fractions. 5e to the power of negative t plus 1. This is itself divided by negative 1, so minus 5e to the power minus t, plus t and a constant, and you're done. So the point being, you may not need an substitution method, so be careful. What I want to do with this question, I want to use the method that most everybody does, and then mine. First of all, this is inside the radical, a polynomial of degree 1, and that's the choice of u. The derivative is 3, which makes du 3 dx. Now, the way most texts do, because this is simple enough, I'm going to go that route. They solve for dx, so it becomes du over 3. So this is the square root of u times dx, or du over 3, which of course means u to the power 1/2. So this, you can rewrite it as 1/3, the integral of u to the power 1/2 du. And move on. This is what most everybody does. What do I do? Well, I just write what I have. I'm going to repeat what I have. And this is telling me, this one is telling me number 3 is missing. So I'm going to put 3 in, 1/3 down. That's what I do. I think it's fast. And I hope you see it's the same thing. And if I want to integrate this, of course, 1/3 is there. This is 1 over 1/2 plus 1, u to the power 1/2 plus 1, and a constant. We've done this a number of times already. 3/2. The reciprocal is 2/3. And it becomes 2 over 9, reversing the substitution, and you're done. But if we were to rewrite it with the square root, we would rewrite it as 2 over 9, 3x plus 7, square root of 3x plus 7 plus a constant in case. Okay. Pretty straightforward. Now, I want to look at this example because I've seen students mixing up differentiation and integration when exponential is involved and trigonometric functions. So if I want to differentiate this, remember, this is itself, but we have to multiply by negative 0.2 minus sine gives you cosine. So minus 0.8 e to the power minus 0.2x, and you're done. If I want to integrate, I have to put a dx next to it. And again, this is the same thing, but this time we're going to divide by negative 0.2. So this is 4 over negative 0.2 e to the power of negative 0.2x, and this one minus sine gives you positive cosine and a constant. So the only reason, because sometimes students mix things up. So 4 over minus 0.2 is 4d over minus 2. And that is negative 2. And we are done. What if we make it into an initial value problem by setting, let's say, f of 0 equals 2? So what you're dealing with is a general solution here, everybody. Because of this C, we have a family of functions. Let's plug in 0. That will help us find the C. Of course, you know this is 1. This is 1. So minus 20 plus 1 plus C equals 20. C becomes 39. Replace it, and it becomes one of those solutions. a particular solution. So very straightforward, everybody.